In lesson 10.5, we are going to take a look at the effects of changing dimensions proportionally. And we're going to take a look at what happens to the perimeter and what happens to the area. So if you jump down to example A, we have a triangle here, and we want to take a look at what happens to the perimeter when our base and our height are multiplied by a factor of 3. Well, as I look at my triangle, I see I don't have all of my information. I have a missing side here, but it is a right triangle, and so I know that I could do the Pythagorean theorem, a squared plus b squared equals c squared, to go ahead and find that missing side. Or I'll go ahead and tell you this is actually a Pythagorean triple, and so you may know this one. Our missing side is going to come out to 5 centimeters. 5, 12, 13 is a Pythagorean triple. So when I take a look at my perimeter, well, I want to take a look at my original perimeter, and I'm just simply going to add up my sides. 5 plus 12 plus 13, and we would find that we have a perimeter of 30 centimeters. Well, what is the effect of change, or what happens when we multiply our base and our height by 3? What would our new dimensions be? Well, if I times by 3, times by 3, times by 3, I can see what my new dimensions would be taking a look at the perimeter of the new figure. If I add 15 plus 36 plus 39, we would find that our perimeter is 90 centimeters. How would we describe the effect of change? Well, from original to the new would increase and actually multiplied by 3 as well, right? So I'm just going to go ahead over here and say my perimeter was times by 3. What about if we had our rectangle with dimensions 4 and 7? And what would happen if our rectangle, the base and the height, was multiplied by half? Well, let's take a look. Perimeter, original. If we thought about adding 4 plus 7 plus 4 plus 7, we know that we would find a perimeter of 22 feet. What would my new perimeter be? Well, if I have multiplied my base and height by half, I now have dimensions of 2 and 3.5. 2 plus 3.5 plus 2 plus 3.5, well, that would actually give me a perimeter of 11. So what happened to my perimeter from 22 to 11? Well, my perimeter is also multiplied by 1/2. Is that always going to be the case? Yes, when you change your dimensions and you change all of them by the same factor, your perimeter is also going to change by that same factor. Okay? What about in example B when they ask us to take a look at the area? Well, we are actually going to use the figures above. So in question number 1, it says the base and the height of the triangle are multiplied by 3. We're referring back up to our triangle here, but now we're taking a look at the area. So of my original, my area, 1/2 base times height, well, I know I'm taking 1/2, 5 times 12. Well, half of 60 is 30, so this would have an area of 30 square centimeters. And my new figure, my area, 1/2 base times height, well, 1/2 15 times 36, that's actually going to give us an area of 270. Now, did that change by a factor of 3? No, when you look here, 30 to 270, well, 3 to 27, that actually multiplied by 9, right? So what was the effect of change? My area was multiplied by 9. What about on a rectangle? When we changed the base and height, we multiplied by half. what was the effective change on the area? Well, my original area is base times height of 4 and 7. So that would have an area of 28 square feet. My new area would be 2 by 3.5. Well, 2 times 3.5 is just an area of 7 square feet. What happened here? Well, it got smaller. And a lot of times people would say it divided by 4. It was divided by 4, which is correct, but we're going to take a look at or think about what it was multiplied by. If it was divided by 4, do you agree that would be the same as thinking about our original area multiplied by 1/4? Well, what do we see here? When our dimensions were changed by this factor, the area changed by a factor of that squared, right? 1/2 squared is 1/4. That's always going to be the case. And we had talked about this a little bit earlier in the year. What about if we take a look at a circle? Describe the effective change on the circumference and the area of the given circle. So if I want to take a look at the change of the circumference in the area, I actually want to go ahead and figure for my original the circumference in the area. But I'll tell you, this is going to be much simpler if you leave these figures in terms of pi, so that we have an exact answer. So 2 pi r, or pi d, would tell me a circumference of 20 pi, and pi r squared would tell me an area of 100 pi. Okay, well, what happens if we want to take a look at our new circle? It tells me the radius is going to be multiplied by 1/5. So if I take my radius and I multiply it by 1/5, I'm now working with a radius of 2, correct? And I want to look at my circumference and my area. Well, 2 pi r, 2 times 2 is 4, so this would be 4 pi centimeters. Pi r squared, my area would also be 4 centimeters, except it's 4 square centimeters. So even though it looks like the same answer, they're actually different because one's linear and one's in square units. But let's look at how they compared the original circumference to the new circumference. Well, it looks like it was divided by 5, right? So my scale factor then, my circumference was actually multiplied by 1/5. What about my area? 100 pi to 4 pi. Well, it looks like it was divided by 25, right? If I take 100 pi and 4 pi, and I want to see how they compare, it could be divided by 25. So my area was actually multiplied by 1/25. Does that make sense? Well, sure. My circumference changes by the same factor. That's similar to the perimeter. It always changes by that same factor. My area changes by this factor squared. 1/5 squared is 1/25. That is always going to be the case as long as we are changing our dimensions proportionally, meaning you're changing all dimensions. So if you flip your paper over, we have a chart that kind of summarizes this. And we had talked about this before, like in chapter 7, when we talked about doubling a figure, doubling the size of something, the fact that the area actually quadruples, right? In fact, you drew some rectangles on your paper and we checked that out. So the effects of changing dimensions proportionally. If your change in dimensions is a factor of A, your base and your height change by a factor of A, like when our triangle changed by a factor of 3, the perimeter or the circumference is also going to change by a factor of A. So our perimeter changed by a factor of 3. but the area is going to change by a factor of a squared, which is why our area changed by a factor of 9. Do you have to always write out the original circumference or the original perimeter and the original area and calculate the new ones? No, you do not. This chart would allow you to determine what's going to happen without having to calculate all of those numbers. So if you can do it without calculating them, then I'm fine with that. Taking a look at example C, they tell us that a rectangle has a base of 10 and an area of 40. The area is quadrupled, and I'm wondering what happens to the perimeter. Now, if you're a person that likes to have a picture or a diagram to go off of, I would definitely suggest drawing that. My original rectangle has a base of 10 and an area of 40. And it says that in the new rectangle, the area is quadrupled. Now, this isn't going to be to scale, but I know if it's quadrupled, it's multiplied by 4, right? So my new area would be 160. Now, I could problem solve to figure this out because I know if this base is 10, then this height is 4. And I could maybe think about what x and y would have to be in order to get this answer and that my figures are similar. But the other thing that I know is that if my area quadrupled, that means that a squared is actually 4. The factor by which my area changed is a squared, and that is 4. If I'm wondering about what happens to the perimeter, well, the perimeter changes by a factor of a. And so if a squared is 4, do I know what a would have to be? Yeah, a would have to be 2, right? And so what's going to happen? Well, I know that my perimeter would actually be multiplied by 2. The perimeter would double. And if we figured that out, we would find that, yeah, in fact, we would have side lengths of a 20 by 8. Question 2, it says a square has a side length of 5 centimeters and the area is multiplied by 9. What happens to the side length? Again, if you like to have a picture, I would say go ahead and draw one. My square has a side length of 5 centimeters and the area is multiplied by 9. Well, I know that this area is 25, and so if I thought about my picture, 25 times 9 is 225. And I could pretty easily figure out what x is and describe what happens to my side length. But the other way to go about this is that if the area is multiplied by 9, the a squared factor is 9. And if my area changes by a factor of 9, my side length is a dimension. So the dimension is going to change by a factor of a. Do we know what a is? Well, yeah. If a squared is 9, a would have to be 3. And so my side length would have to be multiplied by 3, which would be the case. If you come over here, this would have to be a 15 by 15, and 5 times 3 gives me 15. Okay, let's take a look at the last one. The last one tells me that I have a circle with a radius of 6. The area is tripled, and I want to know what happens to the circumference. So if I give myself a picture and my radius is 6, I know that this area is going to be 36 pi, and my area is tripled. Well, if I take this and I triple that area, that means that my new area would be 108 pi. The only thing is that this is going to get a little messy when we're wanting to think about our radius because it's not going to come out very nice here. So I'm going to take a look back up here. If my area is tripled, that really means that the a squared factor is 3. And my circumference, well, my circumference is going to change by a factor of a. So if a squared is 3, what does a have to be? A has to be the square root of 3. So what's going to happen to my circumference? Well, my circumference is actually going to multiply by root 3 as well. What would happen to my radius? Here, my radius was 6. Well, my radius is a dimension. Guess what? This new radius would have to be 6 times root 3, because it would also change by a factor of a. And that's why it doesn't come out super clean here. A little easier to take the shortcut, just figuring out this way. Okay, at this time, I would like you to get started on your worksheet for 10.5. And if you have questions, definitely stop in and see me, or I will talk to you about those when I return.